We've been doing a lot with rational expressions, but the one thing we have not done yet is solve a rational equation. And there are a couple methods that we could use to solve a rational equation. And like with the simplifying rational expressions, the trick is realizing what you're given and then using the appropriate tool. So a rational equation has an equal sign in it. We've dealt with rational expressions. We've dealt with simplifying something like this, and I would ask you to simplify this. Well, that's not an equation. An equation has an equal sign into it. X squared minus 9 over x minus 3. That's a rational expression. There's no equal sign in it. Now we're going to talk about an equation where we actually have to do stuff to both sides of the equation. So if a rational equation is not expressed as a proportion, and we'll talk about that later, you can solve it by multiplying each side of the equation by the least common denominator, or LCD, of each rational expression. What you also have to do, though, when solving rational equations is plug it back in. Must plug solutions in to see if denominator is 0, because we can't have 0 in the denominator. That makes an undefined fraction. So just like how we had to check solutions in absolute value equations to see if we would get an absolute value that equals a negative number, we have to also check our solutions here. So letter A, the least common denominator for this, or this is really over 1, is x. So your LCD is x. So I'm going to multiply everything by x, by x, by x, by x. You'll notice that we're not multiplying the top and bottom by x. We're just multiplying everything by x, every numerator by x. And the reason we can do that is because we have two sides of the equation. When we're doing rational expressions, we would have to do x over x because we're just really multiplying by a form of 1, and that's allowed. But because this is an equation, if I multiply everything on the left side by x, I can multiply everything on the right side by x. I don't have to do x over x. So when we multiply everything by x, we get negative 24x over x plus x squared equals 10x. Now, the x's in the first fraction go away, so we have negative 24 plus x squared equals 10x. We know how to solve that now. That is a quadratic equation, so we're going to add 10x to both sides. Subtract 10x from both sides. And that's going to give us x squared minus 10x minus 24 equals 0. Oh, that's something we can factor. Two numbers that multiply to negative 24 but add up to negative 10. That's negative 12 and positive 2. So x equals 12 and x equals negative 2. So we have to plug those in now to the original, not one of our steps down here. We got to go back up to the original equation given. So negative 24 over 12 plus x, which is 12, equals 10. So right here I'm plugging in x equals 12. So we get negative 2 plus 12 equals 10. And this is true, because 10 does equal 10. So x equals 12 works. And then we're going to try x equals negative 2. So negative 2 over, negative 24 over 2. plus x, which is 2, sorry, negative 2's, equals 10. Negative 24 over negative 2 is positive 12. So 12 plus negative 2, or minus 2 is 10. That works as well. So these two answers, or these two solutions, both work. So we have two answers for this rational equation. Okay, in this problem, our least common denominator is going to be 2 times x minus 1, because we have a 2, and then two of the fractions have x minus 1. So I'm going to multiply both sides by 2 times x minus 1. Multiply that over here as well. Be careful on the left side. This has to go to both things, both fractions. So I'm actually going to write this out a little bit longer than maybe you need to later on. So, and I'm also going to write it like this. Oops. I'm not multiplying the numbers right now on purpose. Because I want you to see, whoops, I forgot to write over x minus 1. Because I want you to see things cancel out. Because if you multiply 2 times 3 and you get 6, you may not realize quickly that these 2's will cancel out. So the idea here, and one of the issues that students will run into, is that they'll try to multiply everything out right away. And in some problems we did do that earlier when we were simplifying complex fractions. And that's why I said it's very situational about what you do. Now, yes, you could multiply 2 times 3 and then 2 times 4 and all that, but then just realize you'd have to reduce the fraction afterwards. So these two cancel, x minus 1, x minus 1. Because what this does is it gets rid of our fraction. So we have 3, and now I'm going to distribute 3x minus 3 plus 2 times 4 is 8 equals 2 times x plus 1. Actually, we can distribute that as well. So it would be 2x plus 2. So now this is a nice linear equation that we can solve. 3x plus 5 equals 2x plus 2. Subtract 2x from both sides. We get x plus 5 equals 2. Subtract 5 from both sides, we get x equals negative 3. So now we're going to have to go up here and plug that in. And I have a feeling that this is going to work because I see my denominator, and the only thing that will make my denominators equal to 0 is positive 1. But we always want to check just in case. So I'm going to check over here where I have some room. 3 over 2 plus 4 over negative 3 minus 1 equals negative 3 plus 1 over negative 3 minus 1. So 3 over 2 plus 4 over negative 4 equals negative 2 over negative 4. So 3 over 2 minus 1 equals negative 1/2, and that is true. Sorry, this is positive 1/2. So 3 over 2, which can be written as 1.5 minus 1 is equal to 0.5. That's a true statement. So our solution is x equals negative 3. So I hope that you're seeing how everything builds off of each other. You know, we first did some simplifying radicals where we saw that things were canceling, and then we did some multiplying and dividing, and that had some more canceling, and then we did some addition and subtraction of some rational expressions, and those skills are helping us here. Right, when we do this problem, what we're going to have to do is first we want to factor the denominator of that middle fraction right here, and you'll see why in a minute. That's x minus 3 times x plus 3, and then minus 4x over x plus 3. So now it should be easy to see that your least common denominator here, your LCD, is x minus 3 times x plus 3. So I'm going to multiply everything by that. Multiply everything by my least common denominator. And what's going to happen is things are going to cancel and we'll get rid of all of our fractions. So I'm not going to write everything out like I did up here and then cancel things off. I'm going to cancel things off as I multiply. Because when I multiply x minus 3 times x plus 3 times 6, the x minus 3s are going to cancel. So now I'm going to be left with 6x plus 18 equals, remember, this needs to be distributed to both fractions. So that's going to cancel off with these two, and we're just going to get 8x squared. And then for the negative 4x part, the x plus 3 will cancel. So I'm going to be left with negative 4x squared plus 12x, because you're multiplying 4x times x minus 3. If you're not ready to make that jump yet, if you're not ready to make that jump just yet, let me just show you what I did. So I did 6 times x plus 3, because that's what I was left with right here, equals 8x squared, and then minus 4x times, well, the x plus 3 is canceled, so I was just left with that. And then I distributed. So that's how I got this line right here. So now we're going to combine like terms, and we're going to get 6x plus 18 equals 4x squared plus 12x. Then we'll subtract 6x from both sides and subtract 18 from both sides, so we'll get 4x squared plus 6x minus 18 equals 0. And now we're going to factor this. So let me do that over here. Factor out a positive 2 first. So once we factor out a positive 2 from this, we are left with 2x squared plus 3x minus 9 equals 0. And then we're going to factor this. You could factor that by grouping, or you could factor it by guess and check. I am going to do guess and check, and the reason for that is because the numbers are easy to work with. Because my a value is 2, the only two factors of that are 1 and 2. So I know that my parentheses have to look like this. Because my c value is negative 9, I know that the numbers that go here have to be 3 or 3, or 1 and 9. Some could be positive, some could be negative. So this is actually going to be minus 3 and plus 3. And you could FOIL that in your head to make sure those are the correct answers. So 2x minus 3 equals 0. If we solve that, x is going to be 3 over 2. And if you look at that one, x is going to be negative 3. Now with x equals negative 3, if I go back and look at my original equation, if I plug in negative 3 into x, even if one of my fractions gives you a 0 in the denominator, it doesn't work. Look at this fraction right here. If I plug in negative 3, negative 3 plus 3 is 0. That can't work. So negative 3 is off the table. 3 over 2, however, can still be used. So let's plug that back in. And honestly, at this point, with all these x's here, I would just use a calculator. you guys know how to do the fraction button on your calculator, and you can do a fraction within a fraction on your calculator as well. And you will see that when you use a calculator for this, you are going to get a true solution. You're going to get -4 equals -8/3 plus 4/3, plus -4/3, which is going to be -4 equals -12/3, which is -4. So yes, this works. All right, let's look at the next page. So what we have here is a rational equation without solving what would be some extraneous solutions if we were to get them. I mean, we're not saying that we're going to get these as solutions, but just by looking at the equation, which solutions would be extraneous? Well, we look at the denominators and see what would make them 0, kind of like our vertical asymptotes. So x equals 1 would be an extraneous solution, and x equals 0 would be an extraneous solution. So we know if we get one of those answers that it is extraneous, and we don't even have to check it. So we'll do this one together, one last one together, and then I'll have you do these three together, or sorry, these three on your own, and check your answers and work after you're done. All right, so with this equation, I'm going to multiply, let's see, our LCD. Let me rewrite this here. Our LCD is going to be x times x minus 1. So I'm going to multiply everything by that. And again, cancel things off. And remember, this has got to go to both. So in the first one, the x minus 1s would cancel. So I'm going to be left with x squared minus, and the x's will cancel. So 2 times x minus 1 equals, the x minus 1s will cancel, so x. And we can distribute this if you want. Or not if you want, you need to at this point. Then we're going to combine like terms, subtracting x from both sides. So then we're going to get x squared minus 3x plus 2 equals 0. And then it's going to factor to x minus 2 times x minus 1 equals 0. So my solutions are x equals 2 and x equals 1. But we know from up here that 1 cannot work. So we don't even need to try that and check that. So you can just try x equals 2, and you will see that x equals 2 will work, but let's just try it. I'm not equal, sorry, minus 2/2. So 2/2 minus 1, so 2/1 minus 1 equals 1. Well, 2/1 is the same thing as 2, so 2 minus 1 equals 1. That's a true statement. So x equals 2 is your only solution. All right, so please pause the video, try these problems. If you need help, go back in the video and see how we did these 4 problems for some additional help. All right, let's look at these and see what happened. The first one should not have been too difficult. Your LCD was 5x, and then you got a nice linear equation, and you got x equals -10. This one, once you get the least common denominator of x times x plus 7, it did take a little bit of work to get through that. You'll notice that I didn't check my answers. I trust that you can use your calculator to check them and to see which one or ones work. Both of them worked, in this instance. And then the last one was a bit of a doozy because you had something with an a value of 5 to factor. And again, I guessed and checked that factoring. So you can see this here. Notice that right here in red, I added a lot of stuff to both sides to make my a value positive. Typically, I would just move the side with fewer terms, but because it was negative 5x squared, I wanted to make that positive, so I moved everything over to the right side. And that's what I did in green right there, to make it equal to 0, but also to give my a value a positive number. So I know that this stuff is confusing. It does take time to get comfortable with. So if you need to rewatch this, absolutely rewatch this. So thanks for watching. Make sure to like the video and subscribe.